SASI boardroom members, are they there?
Yeah.
Oh, okay. Right. So today we are continuing what we left yesterday. For the sake of time and because the recordings are available, and because the procedure is the same, I decided to just quickly fix this so that we go to the shears. It's the same process.
It's as mute your
Is that
audio.
okay?
It's as boardroom. Mute your audio.
Hello? Hello? Have you heard what I said?
No, we didn't hear you.
What I'm saying is, for the sake of time and for the fact that the procedures are the same, I decided to just fix the ESP boundary, or let me say the sulfide boundary, so that we could go to the shears. The procedure is the same. And because the recordings are available too. So this, yeah, so this is the sulfide boundary. You can see that all the drill holes are inside it, and outside we don't have mineralization. Forget about this one. This one looks like it's at a different location. Let me, if I use a ruler, this one try. So let me increase the thickness. This one. So if I use the ruler and measure from here to that, the distance is about 5-point-something kilometers. So it's at a different location. Those drill holes may not be part of Abori, and that was why I ignored them. Okay, this is the ruler if you want to measure. So when you finish measuring, you can just take the arrow. So we see that all the assays, the results are inside the boundary. So that is what we want. If actually, if you want to use this for the estimation of the domain 1, what you can quickly do is you may want to trim down the volume, because you have a lot of it's too broad. You may want to trim down the volume, because if you don't do that, the model is going to be big. You're going to produce a very big gigabyte of a model, which the engineers may not be able to use. So it is prudent to at least reduce the size if you want to, so that you can, they can be able to use the model, not to freeze on the machine. So what you can do is to use pyrite boundary. Can you see my cursor? Pyrite boundary. So if I drag it in, it's a boundary. So I just have to adjust it if I want to. If I want to adjust, at times when you produce the wireframe, it can tilt in any direction. You just have to use the arrows to adjust. I told you that this is the strike, and this is the dip. The other one is a plunge. So what you need to do is you can use these ones to adjust it. The F is front and then the B is back. The F is front, the B is back. You can just adjust them if you want. You can move it back and front if you want. So just adjust it, make sure that it covers the wireframe. And then you go back, edit, You just right click and go to edit. So that you give you that pencil, the editing tool. So when you get this editing tool, you need to make it transparent to be able to see the, and make the wireframe transparent as well. So that you can see the drill holes. You don't want to cut, you don't want your polyline to cut through the drill hole. So you just use that tool. Just click on it, then draw your polyline. Leapfrog, whether clockwise or anti-clockwise, it works. It's not like Sepak whereby you have to finish and then change your string to clockwise, whatever. It's not like that. So whether clockwise or anti-clockwise, it works. So you just trim down a bit. So something like that. And okay for it to run. So think it's done running. Where is that running? You just have to tilt and see whether some of the drill holes, if you might have cut so much to expose the drill holes. So that is not it. So you can use this one, this smaller one for the domain 0 estimation. There are a lot of terms in the resource. So if I mention any term and you don't know, please just raise your hand, interrupt, and then understand, because it is built gradually. You wouldn't just get up one day and understand all the terms. So as we go through this exercise, and whatever I mentioned that you don't understand, just draw my attention, and then I will explain. So somebody may be asking, what is domain 0? Domain 0 is just when you assign all the necessary domains that have a defined trend. The remaining samples that are patchy and some are waste, you can find little samples that are, I mean, of a high grade, but they are in the midst of waste. They don't have any major trend. They are discontinuous. So after everything, our domains, maybe we can name the 1, 2, 3 up to 5 like acquisition domains, and the remaining ones that do not fit into any domain, or they are not qualified into any domain, are termed as domain zeros. So that is the domain 0. Okay, so that is it about the sulfide boundary. The next thing we want to do is the shears. I explained that the shears are, the shear is just developed on a very intense aspect of the mineralization. So the shear is going to sit inside the ASP, or let me say the sulfide boundary, because that one is smaller. It's just the intense aspect. At the end of the day, you may have some domains sitting outside the shears. And if you people have time after this, we'll have to get a very complex data. Then we model, then you see how it is. Okay, so to do the shears is the same way the same mesh table, how we created the mesh table for the pyrite. We're going to use the same procedure to create the mesh table for the shears. So I just go to, already the lithologies are already grouped. The grouping is done once, and they can be used at any time. The grouping is done once, but the shears, anytime you are creating a geological model, you have to create the shears. The mesh. So we just go to the drill holes and right click and say new mesh table. I need the gold. I need the rock group. The lithology and the rock group, they are the same, so there's no need. Here I don't need the mineralizations. I don't need the minerals because I don't need the minerals in the shear. So I only need this one. So for consistency's sake, I just have to say B underscore mesh, then maybe shear. So I name it like that. Then I'll okay it. Okay, so it's done running. I have a mesh table here. I can clear, you see this one, clear scene. I can clear every scene. Then I'll just drag the mesh. So it means that if you are editing the shears and you go and use the Parite mesh table, it wouldn't work. If you are editing the shears and you go and use the Parite mesh table, it wouldn't work. Aha, so take note of that. So my assets are here. Can use same legend. And I told you that to make it cylindrical, you just click on this, make line solid. If you click on that, it's going to increase the line radius, the radius of the drill holes, the samples, maybe to 70. So you can just send it back to maybe 5 or whichever is good for you, maybe 1, whatever. So this is the mesh table for the shears. So just like we created the select underscore Parite in the mesh table of the Parite, same way we're going to create select underscore shears on the shear mesh table. So I just have to right click and go to interval selection, the same procedure we did the last time. So I'll leave the base lithology as none. Then I'll just give it cell underscore. That's a select shear. Then I'll okay it. So the same way, as soon as you finish creating that, because the select underscore shear is empty, the drill holes are empty. These are just traces of the drill hole. Leapfrog creates traces of the drill hole. So if you want to hide them, this is where you can hide them. If you can see my cursor. Okay. So I just change to gold. And remember, this is your legend. If you want to label them, I think when you people get time and then you play on them, you understand better. If you want to label the assays, that is how you label them. So, yeah, so the A is labeling. If you want to label them, legend, you want the traces to come. You want to make them, if you want to change them back to this smaller traces, that is it. So, okay, so let's now go. So when you're done creating the mesh table, what you need to do is, I want to take a section. So I just go on plan, look down. I want to increase this maybe to 2. So with the shears, I want an intense area. So I'm going to start. I will have to select everything. So before you select everything, just remember to select everything and assign it as non-load before you begin. So this guy, select all visible intervals. So if you click on that, and I told you that if you want to deselect, you click on that. Select or deselect. So like that. So here, I'll assign it, create new lithology. Then I'll give it on. Okay. Okay. So then, looking down, I'm going to create the I'm going to create the create sections and then move section by section and do my interval selection. So I just click on this. I just want to define, let me make it define, because at times if you just use a single drill hole, it may not, you may miss you just have this. Then I want to look south. I told you that the step size, you may want to use the drill hole spacing if you want, or whichever, it will work for you. Then use so this will be 20. The slice width 20, and then a step of 10. Half of the spacing. That's the standard, but you can put them 20, 20 or 10, 10 or whatever. The bigger the size, the quicker you finish. Okay, so with this, now I want an intense mineralization zones to select. So what I want to do is I want to set the modeling, my grades, the modeling grades. I want to make the cutoff. I want to give it a cutoff of 0.3. I'm filtering all axes. I mean, acquisition is 0.3. Its axis is 0.2. So it means that 0.2 and above, that threshold is all. Below that threshold, below 0.2 threshold is waste. Yeah, so because this one is shear, I just want to, okay, let me give it 0.2. So this is what I have, and that is what I'm going to select and then assign and create a new methodology. So, and I told you that you use a greater than to move forward section to section, and less than to move backwards. Okay, so wherever you stand, whichever you want to do it, you can always go back and forth. So with this, I just have to click on this, select this. This is the thickness, selection with thickness. So if you click on this is 100, and just observe how small the thing is for selecting small samples. Give it 30. See that it has increased. So I want, because it's shear, I want to sweep a lot of samples. So I give it 100. So assign to create new, then I'll just give it shear. So I'm moving. So with this, just have to move faster. I want to increase for our time's sake, I want to increase the slice width and then be able to move faster. The standard is using the drill hole spacing. Otherwise, we may not be able to finish it in time. So change this to red. Change this to green. So move out and select whichever direction you select to go. At the end of the day, leaf roll is going to form a hanging wall, foot wall, hanging wall, hanging wall, hanging wall, hanging wall, foot wall, foot wall, foot wall. So whichever you select is okay. At times, when you are dealing with several loads, you can forget and then assign to the wrong load. So after that, you can check, move your sections and then try reassigning them. So I've ended this section, so I have to go back and then to be able to identify which section, I'm going to pull the axis in, then change this one to select underscore shear. I want to hide the non-loads. Here, I want to hide the non-loads. So it means that this section was, selected. Let me change this to this. Change this. Changing this. Okay, so I want to make this one bigger. But I will make this one smaller. 0.5. Now filter. Okay, so uh, 0.2. Okay. Okay, so So what you'll be doing until you finished. When you are selecting, you see this sample, very small in the middle of this and that. I want to ignore it because if I select it, it's going to form the hanging wall and the foot wall. So it will pinch the shear at that point. So I just don't want to do that. I can also do it, but at the end of the day, you have to suffer ignoring all those small samples. So if you select a sample and it's not selected, it means that it's not on the section that you are selecting. See that this one has refused to select. So those who have been selected, this in the sample is on the section that you are dealing with, but the rest are not on that section. So when you get to that section, those samples will be selected. Oh. Hello, Benjamin. Yes. Can I call you back? Yes. Thank you. Yeah. All right. So I could have ignored this hole if I want, because it will form a hanging wall here and a foot wall here. And these are going to form hanging walls here, foot walls here. So it will distort the wireframe. After that, I can unassign it if I want. Somebody may ask, why am I selecting all? I have filtered the grades to 0.2. So whatever you are seeing on the screen is 0.2 and above. We don't have zeros there. At the end of the day, if you think you still want clarity on what we did yesterday or today, you can just ask me a question concerning that. There may be some samples I haven't selected because at first it was the select underscore shear was active. It will never select these assays. These assays are not part of the mesh table, so it will never select these assays. It's dealing with the assay here on the mesh table. So I may have to go back and select some. I think this was these drill holes or the samples were grade control. So you see them clustered on top. So at the end of the day, because they are short, they will form hanging wall, footwall, hanging wall, footwall. So you have to come back and unassign everything on those aspects and use the exploration data as your hanging wall, footwall. Now this version of leapfrog is better. The one before this, the version 6 point something, that one you have to ignore the samples one by one. One by one, you can't select everything and ignore. So you can click million times a day. I beg, let me find out from Bishop whether he's able to join us. Hello. Hello, team. Is there anybody who is using his or her phone for this team?
I'm using my phone now.
Bishop says he can't join. How did you do it? If you could assist him.
With me, I just downloaded Teams, and after registering, everything worked. I don't know, probably it might be his phone. Sometimes it has to be the phone that you are using.
Like, let him check his data. Let's see.
Yes.
I'm saying that let him check his data because I also joined. I think yesterday I joined with my phone, but I didn't have the team. I just used
his phone, and
he said check his internet connection.
Paco, you were suggesting something there.
It was Junior. Yeah, Junior, go ahead.
Yeah, Clet.
Yes.
You should download the Teams app, and then you should go back to the link, and you just click on it, and it will come.
Hello, Bishop.
Hello.
Yes.
Download the Teams app, and then get back to the thing. You have it already, right?
Okay, yesterday when I joined, I didn't have the app. I just clicked it and then I used my internet. So the internet should be stronger.
Come again.
I'm saying if he doesn't have the app, his internet should be stronger. So that he can join directly from there. Then if you go back to the link and just click on it.
He has the app already.
I'm sending you a link. So I'm saying that you should go back to the link. You should click on the link and automatically to come.
It's open through the app.
Your mail, I don't see the link. I have it in my calendar. So I go into my calendar.
Yeah, you go into your calendar and just follow the team. Click on it.
I think someone can even send it to you through your WhatsApp.
Somebody should send what video?
No, somebody should share the link to him through the WhatsApp and then he can join from there.
If you have, is there anybody who has
right
the
away,
link on WhatsApp? I mean, just send it to him on WhatsApp.
Okay, I'll do that. Let's. Where's
Okay,
Michael?
Mike is sending you the link through WhatsApp.
Yeah, we have sent it to him.
Okay, all right. So we're almost there.
Okay, hello, collect.
Yes.
So I've sent Wasandi the link via WhatsApp, so he can use it, and I've sent it to Gina as well, so any of them can use it.
Okay. So I'll call him and find out whether he has.
Yeah.
Wish we could.
Hello.
Yes, sir. Mike has sent you through WhatsApp. So I'll send the link through WhatsApp.
Okay. Right. Thank you.
Some of these things, if you have the time to watch the video over and over, you can just close your eyes one day. If you get a license, just do it. It's not. It's just a long process. Not that it's difficult. Yes, welcome. Yes, sir. Hello, Bishop.
Yeah, correct.
Aha. So, can you see my screen?
Yes, I can see your screen now.
Aha. So, what we are doing is we're trying to model a wireframe around the intense mineralized area. It's also another big envelope which is not of importance to estimation, but it can also be used for the domain zero. It can also be used to estimate the domain zero. That is if we so decide that the ASP boundary is big. So we are done with the ASP boundary. We are now on the shear.
Okay, thanks.
Yes, and I have sent the recordings. I think you are on copy. You are in copy, please.
Okay.
So after this, that will now define the estimation domains inside what we are going to create now, the shears. So this is a grade of 0.2 and above. When I'm done, I'll filter grade of 0.3 and then define the domains. So we have maybe up to, the last time I did, I had 5 domains inside. Hey, this time is already 5.
So I'm the only one around at the moment for next year, so I think we can continue for a while.
Are you talking to us?
Yes, I'm seeing those of us coming for night shift, we're already at the office, so we can continue for a while.
Okay, so I'm going to save it. All right, so I can clear my screen. I just want to show Bishop that this is the ASP boundary that we did. The pyrite or sulfide boundary where the data.
Okay.
So we only have to decide whether this is going to be used for the domain zero estimation or the shear boundary that we are creating. So the shear boundary is going to sit inside this sulfide domain.
Yeah.
And then the various domains that we are going to define are also coming to sit inside the shear. So this is constraining the shear, and the shear will constrain the domains that we are going to create.
Okay.
And if you have caught inside the want to model, the code will also sit inside the various domains that we create.
Yeah. So this is why this is why you got to understand the genesis of the deposit, so that when you have all these domains, whenever you are adding them, you add them in logical sequence, else it will not be representative of the deposit. So let the team be aware that it's important you understand the genesis of your deposit, what controls it, which one comes first, which one comes next, so that it aids you in your adding of the domains. That's overprinting your domains.
Yeah. Good. So I think the time is already fast spent. So so Bishop has said it, the importance of the genesis of the ore body. So let me quickly create the geological model for the shear. We will continue the editing tomorrow. So to create that, we have created a mesh for the shears where we have our select underscore shear inside. That is where that is what hosts your selections. So you just come to geological models, right click in a new. So remember when we were creating the sulfide model, what we did was we had to adjust all these ones. We had to adjust them because we've already adjusted them for the sulfide. We are and the shear is going to sit inside the sulfide. Then we just have to pick the sulfide extents, and that is it. So on the base of lithology, you are selecting your self shear. Remember when we were doing the sulfide model, we selected its selection for the base lithology column. Now it is a shear, so we're taking the shear. And I told you that the surface resolution is the length and breadth of the triangles that it will create in the mesh, or let me show you this. So talking about this, can you see the triangles? The finer it is, the better. The finer it is, the better. Yeah, so I can use a ruler. Yes. Oh. So we remember we selected adaptive. Adaptive is wherever it's too close or it has an edge or there's a curve and it's going to form a smaller one, it will form. So it is flexible. That is why the adaptive is always selected. So at a place that's curved or at a place that the drill holes are too intense, if it needs a smaller resolution, it will adjust itself and give us a smaller resolution. So I'm going to give this one 20, and I click adaptive. Over here, you don't bother about the extents. You just drop down the enclosed object and then use the parite extent. So the extents that you use for the parites is the same extent that you are using for the shear. Remember?
Hello, Collect.
Yes.
Collect.
Yes.
Hello.
Yes, I'm.
Collect.
Yeah.
Can you hear me?
Yes, I can hear you.
Yeah, you said you were going to choose 20 for the surface resolution, but you've chosen 200. Okay, you've corrected it. Yeah.
Yeah, I think because there was already 0 there. So when I added it, the 20, I've corrected it. Thank you. Okay, so we just have to name here B underscore. Then we okay it. So this is the shear. So you come to surface chronology. And then you right click and then say new vein from base lithology. Select that. So the vein lithology is going to be your shear. And the name shear is has come. So that is it. So you okay it. So it's running. If you have a question, then you can ask. Okay. So this is how it will look like. It's just like the sulfide boundary we created, saw how it looked like. So we have to do the editing again. You have to ignore hanging wall, footwall, shears, the points. See those points, you have to ignore them. You have to ignore them to get a smoother wireframe. So tomorrow is basically going to be ignoring this so that you understand better. If we finished and then we set to chop off, we will set it to chop off what we are seeing, outside. So if you set the lateral extent like this, so this is the last thing that I do for you to see. Then we just close it tomorrow. Remember, because we use I'm going to delete the boundary for you to see something. Delete polyline. So in Leapfrog, you can prioritize whichever task you want to run. When we've built the model up to the lows, because they are linked, they are live linked. All the items will be updated. So you have to choose whichever item you want to update. Yeah, so you see that it will sit inside. You see the beauty tomorrow when we ignore all these samples and reset the reference surface like we did yesterday. Reset the reference surface like we did yesterday. That's where you see the beauty of it. So this is the end. Tomorrow we shall continue. And I think the time is too short. The 1 week wouldn't be enough. But let's try and see.
Yeah, so we will keep on going. So we see that at least the basics are now well understood by all. So let us not restrict ourselves so much to the 1 week. I think if we go beyond 1 week also, since we don't have so much on the field, we can take the opportunity and acquire this knowledge as far as possible.
Okay. That is fine. Okay. So.
Thanks so much, Clayton, for your time and the energy taken in preparing this and impacting the knowledge to the young Jews. Please, as I said it during the first section, take this serious, try to practice it yourself, then come out with your questions. If you don't do that, we'll finish and you wouldn't learn anything. So just make time by yourselves and then practice and discuss issues. Okay.
Yeah.
Okay.
Play.
Yes.
Yeah, the data. And because without
Okay, sir.
The dynamite data.
Yes.
Okay, I'll just do that now. I think.
Yeah.
Bishop.
Yeah. Clet.
Yes,
what we need to do is to fine-tune the data, because as it is, and for the use of beginners, they may have some challenges.
Yes.
So let's fine-tune it. It's not necessary having the entire data. We can subset it and then give it out as a training data.
Yes. I think the data that I saw you display, they look fine. Oh.
Yeah, I sent that one to you.
You have sent it, or you yet to send?
Yeah, and I think I sent it.
No, you didn't send. The one you sent, no, and I disobeyed them. They were different from what you have. So you said you were going to get back.
Okay. It's sitting on my machine. I don't have it on my laptop, so unless I come to site.
Okay. So they will now have to choose whether they want it like that or they will wait for you to come.
Well, they can start with their own data if they have any drill hole data with color assays, lithology, downhole survey, any small data at all they can start with.
Okay.
But when I come, I will fine tune that data so that it becomes one for us all.
Yes. Okay. If they are prepared to learn, we just have to do this, run the estimate for them to see. Then we take complex data. The more you use, I mean, you use lots of data, the more the knowledge in the wireframing.
Yeah.
So if they are prepared to learn after this, we can get more complex data and get maybe the easiest one for them to practice. So if I use the complex data and then do it for them to see, then they can use the one that is less complex to practice on their own.
Yeah, I agree.
So now this one, there's a lot of work to be done. Do you want me to wait for you, or I can edit it tomorrow for some time before you come in, whichever you want? Because
you can just subset and take a very small data for them to practice.
Okay.
Yeah.
All right, then we'll call it a day.
Okay. Thanks so much.
You too. Bye.
Why else see?